Welcome to our resistivity lesson. So the resistance of a conductor will depend on three things. The first thing would be the material of the conductor, because depending on the material, it would help pass the current better or not. The other thing would be the length of the conductor. So if the conductor is really long, you're going to have more resistivity there. And then lastly, the cross-sectional area. So if you have a really thin conductor, again, that would make it more resistant for current to go through as well. So think of a water pipe and the water flowing through it. The water can be resisted if the pipe is really long, or if it's too narrow, so you have less cross-sectional area, or it's just dirty. We can calculate resistance as follows. Remember, resistance has unit of ohms. So R is equal to rho, and looks kind of like a P like this, the length over the area. So P rho is called the resistivity, and it depends on the material and the temperature. So generally, metals increased their resistivity with temperature and non-metals decreased their resistivity with temperature. In some cases, the temperature of a metal is brought to negative 273 Celsius below zero. This is known as the superconductor. And you should probably highlight that as well, just so you remember what a superconductor is. Let's try to apply this to an example. So what is the resistance of a 150 meter copper wire of diameter 2 millimeters? And the information missing here is rho, your resistivity for copper wire. I'm just going to give that to you, and they usually will give you what the resistivity is. Okay, so the things that we need are L, the length. So we have the length is 150 meters. We need our area. So it's a copper wire, which means that our cross-sectional area is circular. The area of a circle is pi r squared. We've been given the diameter, and we need to plug in the radius. So we're going to need to first convert this, the diameter, into meters, which is 0.002. Okay, so let's put this into our formula. Remember that we had the diameter, so to get the radius, we do need to divide it by 2. And then you're going to put this into a calculator. You should get 3.14 times 10 to the power of negative 6 meters squared. And then for rho, we have 1.7 times 10 to the power of negative 8. Ohms meters. So R is rho times length divided by area. I'm going to plug all that information in, and then you should get 0.81 ohms. So there is a relationship between temperature and resistance. The change in resistance can be calculated as the temperature coefficient of resistivity multiplied by the resistance at temperature initial multiplied by the change in temperature. So I'm going to summarize all of these variables. So the change in resistance, also known as resistance final minus resistance initial. Then this is the temperature coefficient. Of resistivity. We also have the change in temperature. And lastly, R is the resistance at temperature initial. So let's try to apply this in an actual question. What temperature change has occurred if an aluminum wire's resistance changes from 11 ohms to 35 ohms? Again, the information that seems to be missing in this question is usually should be given to you is the temperature coefficient of resistivity for aluminum wire, and that should be 0.0039. Okay, so we're looking for the temperature change, which is delta T. I need all the other information. I already been given the temperature coefficient. I have the change in resistivity because it went from 11 to 35 ohms. And then lastly, I need the initial resistance, which is 11. Okay, now we're gonna plug this in, or I could just rearrange first and solve for delta T. So then it would be delta R divided by the coefficient multiplied by R. So we have 24 over 0.0039 multiplied by 11. So our change in temperature is going to be 560 degrees Celsius. So there are a few things that we need to know before we jump into the circuits part of this unit. So a circuit is any combination of potential source and resistors. In this case, a resistor may be a light, a motor, a heater, any device that really needs a current. And there's two different types of circuits. The first one is a series. So we have the switch, we have a resistor, another resistor, another resistor. I just drawn 3 resistors. So this is a series and it has one path for the current. For example, it looks something like this. This is the only path that it could travel in. Now your parallel circuit has more than one path. So here is the switch. Let's just say it looks something like this, where we have more than one path for a current. So for example, it could go through just like that. That's one path. It could also go another path this way. And then lastly, you have another path when it goes on the inner one in here. So a parallel circuit occurs when you have multiple paths for the current. And if you want more diagrams, I do have some more on the side here that you can take a look at. Again, this would be a series because it has one path. You can just look at our arrow. In our parallel circuit, you have more than one path. So this is one path under the one, like this. Then you have your second path, which could go like this, third path and fourth path, and so on. So Kirchhoff's law of electric circuits state that the voltage around any complete path in a circuit and the sum of the increases in the potential is equal to the sum of the decreases in the potential. Also, current at any junction point in a current, the total current into the juncture is equal to the total current out of the juncture. we'll be referring to these laws a lot. So I just want you to take a note of these laws and know the difference between a series and a parallel